When you're working with similar figures, you can use proportions to help you find the length of missing sides of any shape. For example, here we have two triangles that are similar in size. They're similar. That meaning they have the same shape and their angles then are also congruent. That means that even though one is smaller than the other, the angles have the same measure. What you have to be careful of is that you are looking at the correct sides, the corresponding sides. Meaning that if the shape is turned, you still are looking at what would be the base of the triangle what would be the legs. Remember, the legs is what we call the sides of a triangle. So, for example, when I look at these triangles, I know that this angle corresponds to this angle, meaning that they're the same. Sometimes you'll see those curves in there to show you that those angles match. Up here, this angle would match this angle, and this angle matches this angle. So you see the angles that correspond have one curve, two curves, and then three curves. So that way you know that they match. What I'm going to do is I'm going to set up a proportion to solve for the missing angle. I know that this side, the 10, corresponds to the 5. So that's going to be my first ratio. My 10 corresponds to my 5. I'm going to keep everything in the same order. So let's say this is triangle A and this is triangle B. You'll notice that I have the dimension from triangle A on the top of my ratio and the dimension for triangle B on the bottom. On the second ratio that I set up, I'm going to keep it the exact same way. I'm going to make sure that I have the length of the leg of triangle A on the top and the length of the leg of triangle B on the bottom. So triangle A, this side is 12, and that's my missing side. So that's the one that I want to use. So now I can cross multiply and divide, just like we used to do when we worked with proportions. So I'm going to multiply 10 times x, and that is equal to 5 times 12, which is 60. Now I need to solve for x, so I'm going to divide both sides by 10. So x equals 6. That means the missing length of this leg is 6. Let's look at another example. It doesn't matter what the shape is. It can be triangles, it can be parallelograms, it can be heptagons. It could be any shape that we know are similar. These two shapes we know are similar. So we're going to say that this is, that's not even a parallelogram. This is quadrilateral A. Sorry, Penny's playing with her pig again. This is quadrilateral B. So now what I need to do is set up my proportion, making sure that I have everything in the right order. So if I'm going to put A on the top, I'm going to make sure that in my proportions I keep A's information on the top and B's information on the bottom in both of those ratios. This first ratio is going to be my known. This is going to be where I have two corresponding sides and can complete that ratio with all of that information. My second ratio is going to have my unknown. That's where I'm going to use my x. So since I want quadrilateral A on the top, I can see here that these sides are corresponding. They're the same side in both quadrilateral. And so I'm going to put my information for A on the top and B on the bottom. Then for my unknown, I'm going to use this 14, and it stays with the A level of my ratio, and my x goes on the bottom. Now I need to solve for x using cross products. 20x is equal to 14 times 10, which is 140. And then I'm going to divide both sides by 20. 140 divided by 20 is 7. So then I know that x is 7. sometimes you're going to find that the similar shapes are rotated, and you still have to find what that missing side is. So you have to be extra careful in this situation to make sure that you are picking the correct sides. In this case, it's not going to be difficult because we only have 2 measurements labeled on each of these. A problem that we're going to do here in a second is going to be a little more complicated. I'm going to say that this is my triangle A, this is triangle B. So again, I'm going to make sure that I keep everything in the correct order, because if I don't, that's when mistakes will happen. When I look at this, I can tell this is a base, this is a base. So I'm going to keep that information in one of the ratios. So 48 will be on the top because that's in triangle A, and 6 will be on the bottom because that's what's in triangle B. And then triangle A is my X this time, is my unknown. And triangle B is 5. So I've kept these sides together in my proportions, making sure to be very careful I set it up the correct way. Now I'm going to use cross products. So I've got 6x is going to be equal to 48 times 5. Now that I need some doodle work for. 5 times 8 is 40, 5 times 4 is 20, plus 4 is 24, so that's 240. And then I'm going to divide both sides by 6 to isolate my x. 240 divided by 6 is 40. So then this side of triangle A, this leg, is 40. Sometimes you've got something super complicated like this guy. You can see we have trapezoids here. And with these trapezoids, we have lots and lots of measurements, and we need to figure out what that missing measurement is, what that X is. So I'm going to say this is trapezoid A, and this is trapezoid B, and I'm going to use that to help me keep everything nice and organized. It doesn't matter which set of sides I use. These have every side labeled. It doesn't matter which one I use, as long as I use the corresponding sides in both of the figures. So, for example, you don't want to use this side piece of 4 along with this 91 in the same ratio. You have to make sure that you are picking the sides that match. For example, if you were going to use the 4, you would want to use the 52 because those are the corresponding sides in those 2 figures. So, and I'm going to actually choose not to use the 52. Actually, you know what? I am going to use it. Why not? So for A, we have 4. B, we have 52. I need X in B. The corresponding side to X in B would be the 11 in A. So in A, I need that 11. And in B, it's going to be that X. So then I'm going to use my cross products. So 4X is going to equal 52 times 11, which is 572. And I know that because I'm using that 11's trick that I've shown you guys. Then I'm going to divide both sides by 4. So 572 divided by 4, I'm going to need a little bit of work for. That would be 3. Nope, sorry, that would be 4. 16, 143. So X would then be 143, would be the measurements of that side of that trapezoid.